Alright class, today we're going to start, we're going to take some notes on the end behavior of polynomial functions. And we've talked about this a little bit in class, just a little bit, but we're going to actually do some note taking and discuss it further. So when we look at the end behavior of polynomial functions, we always want to look at their degree and the lead coefficient. So here I'm just saying with a degree n and a coefficient ax. So when our a is positive and our degree is even, our end behavior of our graph is going to be up and up. So what that means is both ends on the left will be up and then on the right will be up. So no matter what shape we have, an even degree polynomial will both be pointing up if the a is positive. Now if my a is positive but my degree is odd, then I'm going to be down on the left and up on the right. So I would look something like that, where I'm down on the left, up on the right. So if you think about this as a straight line, if I pull the ends apart, we'll be going in a positive direction. Okay, if my lead coefficient a is negative and my n is even, I'm going to be going down and down. So both ends of my graph would be going in the negative direction. Okay, if my a is negative but my degree is odd, I'm going to be up on the left and down on the right. So we'd be going in the opposite directions, like that. Okay, so the thing you want to remember here is that even degrees, they always face up or down. They go in the same direction. Up if it's positive, down if it's negative. Odds are in the opposite direction. If my a is positive, it's going up like a linear, or it's positive this way. And then if my a is negative, it's like a linear function like this, where you're up on the left and down on the right. Okay, so let's look at a couple polynomial equations and see how we would identify the type of end behavior just based on the equations given. So let's look at this first example at y equals 4x cubed minus 3x. Well, if I look at this, I want to say, okay, what is my lead coefficient? My lead coefficient here is a positive 4. Okay, is positive 4. So that tells me, if I remember correctly, if my a is positive, I'm either going to go up and up or down and up. And the next thing I need to look at is my degree here. So my degree is a cubed. So it tells it's 3. So it's an odd number. So based on the chart that I looked up, I'm going to be, degree of 3 is odd. My a is positive, so I'm going to be down on the left, up on the right. Okay, this is not exactly how that graph would look, but I know this would be the ends of my behaviors. Okay, and then on the next example, my lead coefficient is -2, and my degree here is 4. So I have an even degree and a negative coefficient, so I know I'm going to be down and down. Down on the right and down on the left. Okay. Now another thing we know with our graphs is we can look at and we can determine our real and imaginary number of solutions from the graphs. So one thing I need to talk about here is the fundamental theorem of algebra. What the fundamental theorem of algebra tells us is that my number of degrees is going to be equal to my solutions. So again, let me write this out. The fundamental theorem is that the number of degrees is equal to the number of solutions we have. And we talked a little bit about that in the quadratic units, where we had x squared functions. We always looked for 2 solutions. So let's look at these examples here. So now here I have a degree of 4. So based on the fundamental theorem, I need 4 solutions. Okay, so let's look at the graph here. This is a 4th degree polynomial. My in behaviors are down and down. So if I look at that, that tells me that my lead coefficient is going to be negative. It's going to be a negative because I'm going down on both of that. Alright, but let's look at see how many number of solutions I have. Number of solutions is how many times does it cross the x-axis. So I say, okay, across there, and across there, there, and there. So if I count them, 1, 2, 3, 4, I have 4 solutions crossing the x-axis. So I have 4 real solutions here. Alright. Okay, let's look at the second example. My degree is 3, so I need 3 solutions. Okay. My end behavior here is down on the left, up on the right. So that tells me I have a positive lead coefficient. Okay. And how many real solutions do I have? Well, I cross, there's one, and there's one. So I had 3 solutions crossing the x-axis. So these are 3 real solutions. Okay. Our last example we're going to look at here is another third degree. So I know that the fundamental theorem, I have degree of 3. I need 3 solutions. So let's count how many times we cross the x-axis. Well, I'm only crossing 1 time here. Alright, so if I look at this, that tells me I have 1 real solution, but I need 3 solutions. So that tells me I can't see them. So that, again, it tells me there are 2 imaginary solutions. Alright, one thing we need to remember, and we talked a little bit about this in the quadratic unit, is that these imaginary solutions always come in pairs. They always come in conjugate pairs. And if you remember, conjugate pairs are the opposite operations of each other. So they always come like a plus bi and then a minus bi. So we'll have like a conjugate pair there where we have 2 imaginary solutions. Alright, I want to take a minute and go back and look at our graphs here, and we're just going to remember what we talked about earlier this week about turning points. Remember the definition of turning points, that a polynomial graph would have at most n minus 1 turning points of the degree. So if the degree of n here is 4, at most I'm going to have is 3 turning points. So here is 1 turning point here, a turning point here, and a turning point there. My degree of 3 would be, at most, I would have 2 turning points. And you see it that I have a turning point here and a turning point here. So those are my 2 turning points. Now if we look at this degree of 3 here, we see the same thing. I have a turning point here and a turning point here. So that is 2 turning points. This is only 2 turning points here. So again, we've got to remember that our turning points of the graph is at least n minus 1, and where n is the degree. Okay, and we'll look more about that in class. So make sure you take any notes you have, any questions you have, bring them to class tomorrow, and I'll see you in the morning. Don't forget to complete the form following the video.